All right, check your understanding for 3.1.1b, really working on simplifying fractions. This video is for the mild problems. So we're going to simplify the following fractions using the GCF, or the greatest common factor. So the first step is you need to find the factors of both of our fractions. So we have a factor tree for both 3 and 9. 3 can only be factored into two numbers, and they are both prime numbers. So we are looking for those prime factors. And then 9 similarly is just 3 times 3, which are both prime numbers. Then we would take the fraction and rewrite it as a multiplication sentence of our factors, which 3 would turn into 1 times 3, and 9 would be 3 times 3. Then the next step is we want to create some giant ones. So we look for anywhere that we can create 1 by having our factors be equal to 1, because we know that any number divided by itself is equal to 1. And that can translate into a fraction. 3 divided by 3 would equal 1. So here we have a giant 1, which then would lead us to rewriting the fraction with our giant 1 here. And because we only have a 1 giant 1, we don't have to rewrite anything. And then our simplified fraction would be what would be left. So the simplified fraction of 3/9 would be 1/3. All right, moving on to 4/8. First, we want to do the factor tree for 4 and 8. So we ask ourselves, what times what would equal 4? 2 times 2 is equal to 4. These are both prime numbers, so I'm going to circle them. Then I'm going to come over here to 8. 2 times 4 is equal to 8. 2 is a prime number, so I'm going to circle that. Then I can further factor 4 into 2 and 2. Then I'll circle the 2's because those are prime numbers. The next step is rewriting our fraction as multiplication problems using our prime factors. So we have 4 is 2 times 2, and then we have 8 is 2 times 2 times 2. Then the next step is finding our giant ones, or where we have a fraction divided by itself, which would equal 1. So we have 2 divided by 2, which would be equal to 1. We have another 2 over 2, which would be equal to 1. And then we have nothing left. But we also know that any number times 1 equals itself. So we have a leftover kind of 1 right here. That's just implied. So we are going to rewrite our fraction combining our giant ones. So 2 times 2 is 4. 2 times 2 is 4, and we can rewrite that as our giant 1, times 1 over 2. And whatever is left over would be our simplified fraction. So the simplified fraction of 4/8 would be 1/2. All right, moving on to 15/25. First, we are going to do our fraction trees, or factor trees. So I know that 3 times 5 is equal to 15, and these are both prime numbers, so I'm going to circle them. And then over here, 25 is 5 times 5, and both of these are prime factors, so I'm going to circle them. The next step is to rewrite the fractions as multiplication problems. So 15 is 3 times 5, and 25 is 5 times 5. Next, we're going to look for our giant ones or fractions that are itself over itself. 3 over 5, that is not equal to 1. 5 divided by 5, or 5 over 5, is equal to 1, because we know any number divided by itself is equal to 1. And here, because I only have one, I don't have to rewrite this and combine my ones. So I know that 3/5 is my simplified version of 15 25ths. For the back, we are going to be dealing with this dot pattern right here. So if I notice, figure 1 has 1, 2, 3, 4 dots. Figure 2 has the 4 dots from figure 1 plus another row. We're missing figure 3. Then we go to figure 4, which has the figure 1 dots, the figure 2 dots, and then 2 more up top. And then we are missing figure 5. So in looking at the first question, it says draw the third and the fifth figures, so the figures that are missing. So if I'm looking at what I know to be true with figure 1 and figure 2, we are adding one more row of 2 dots. So figure 3 is probably going to be figure 2 plus 2 more, which would be equivalent to 8 dots. And then if we look on, 1, 2, 3, 4 plus 1, and then figure 5 would be 4 plus 2 more. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 plus 1, and then up the other side, which would be equivalent to 2, 4, 6, 7, 8, 9. Oh, 2, 4, 6, 8, 10, 12. There we go. I can count by twos. 12 dots. 2, 4, 6, 8 dots. All right, down here. If one notebook costs $1.25, how much would 3 notebooks cost? So if I know one notebook costs $1.25, and I want to know how much 3 notebooks cost, I can go about it in a couple different ways. I could do added numbers. So $1.25 plus $1.25 plus $1.25. Or I know that repeated addition is also multiplication. So I can take that number, which is $1.25, and I can multiply it by how many I have, which is 3. So I have 3 times 5 is 15, and I carry the 1. 3 times 2 is 6, plus 1 is 7, and then 3 times 1 is 3. And then here I have a decimal that is moved over 2 spots, so I also have to move my decimal here. So I am left with 3 notebooks cost $3.75. And our final problem at the bottom. Stacy exercises 3 days each week by walking around the soccer field near her home. So she is exercising 3 days each week, so 3 out of 7 days. The field is 80 yards wide and 150 yards long. So these are important facts, so I'm going to circle them. Draw a diagram of the field. So a diagram is just a visual representation of the field. So What I know about soccer fields is that they are in a rectangular shape. So I know that 80 yards wide is probably going to be my smaller side, and then 150 yards long. 150 yards here. And then what I know about rectangles is that the opposite sides are equal to each other in length. All right, so I drew my diagram, check. Then find out how far Stacy walks in one trip around the field. So we are just, if she starts here, if Stacy's starting here, she's going to walk here, which is 80 yards. From here to here, which is 115 yards. Then she'll walk down, which is another 80 yards. And then back to where she started, which is 115 yards. And I would just add those numbers together. So I have 0 plus 5 plus 0 plus 5, which is 10. So I leave the 0, carry the 1. 1 and 8 is 9, plus 1 is 10, plus 8 is 18, plus 1 is 19. So I leave the 9 and carry the 1. And I have 1 plus 1 plus 1 is 3. So she walks a total of 390 yards.